January 2022, Further Pure Maths Paper 1 from Pearson Edexcel, IGCSE. Let's just do it. So calculus here. Going to integrate this, cos integrate straight to sine, and then we just divide by 4 because of this 4 here. And then we're going to evaluate between these limits. This would be a fantastic question if this wasn't a calculator allowed paper, but unfortunately it is. So this is really boring, and you literally just type it into a calculator and you get your answer. So what a waste of everybody's time. F of x is this. We're going to complete the square. I generally just complete the square on the first, or factorize out 2 from the first two terms, ignore the 5. So that's what I've done there. And then complete the square on just this bit here, just ignoring the 2 and the plus 5 over here. So complete the square here, makes x minus 3, all squared, and then minus 3 squared, which is 9. And then you can expand the 2 out again to get this, and then you can collect together these last two terms to get that. And of course, you can expand all this out and just double check that you do get back to where you started, and you should be, and if you do, then you've got it correct, I guess. Hence, find the values for this. So f of x is this, minus 37 is greater than 0. Can collect those two things together and move them to the other side. We can divide by 2. Now, here we're looking for a number which squared is greater than 25. Now, anything bigger than 5 squared is greater than 25, so x minus 3 could be bigger than 5, or anything less than minus 5, because like minus 6 squared is positive 36, which works. So either bigger than 5 or less than minus 5, solve each of those two things, and we'll get our answer. It said the set of values. I'm just wondering now whether I should have written this in set notation, but I don't. If I did, apologies, I should have written that in set notation. But anyway, cool. I don't know. I haven't checked the mark scheme. Geometric series G, so let's immediately get out the stuff to do with series from the formula book, is this. So it starts with A, and then the next term will be AR, because you times it by R, then AR squared, then AR cubed, and so on. So the fourth term, sorry, the second term here is clearly just AR, so AR is 5/16. And the fifth term is just going to be AR4, right? 1, 2, 3, 4. Fifth term will be AR4 is this. And now, of course, we can just do this one divided by this one, because if we do this divided by this, the a's will cancel, and r to the 4 divided by r is just r to the 3. And then type in the calculator this divided by this, and we'll get that. Cube root it, and we'll get that. And then we can just sub that into there, and we can times by 4 divided by 3, and we'll get that. And then we can just say, well, it's convergent, apparently, so the exact value of s, sum to infinity is a over 1 minus r. So the sum to infinity is just this, divided by 1 minus that, and you type that into calculator, and you get this. Lots of calculator use makes this quite quick. Can I draw straight lines? Well, I think I can. Gradient to y-intercept minus 4 is here, and then we go across one box up 2 boxes to there, and we draw the line. Here we can rearrange this one and do the same thing. So y-intercept of 4, and then we go this way, because it's a negative gradient. Rise is 2, and across is 3, so we get over to there, and we draw that line. And then this one here, one more time, rearrange, negative gradient again, negative 2, gradient negative 2 as well, gets you to there, and then you draw that line as well. And then we can shade the region. Shading in PowerPoint is annoying, so I just labeled it R. Find all the points R that do this. Sorry, for all the points that we do this, find the least value of P. Now, you just need to know for this question, apparently, having actually looked at the mark scheme for this one, because I didn't know what the expected way of teaching this was. There's a few ways of doing it. But you just need to know that the vertices of the region are the critical points that you just need to test. So if you ever see a question like this, the expected way of doing it is just to test the vertices. So this vertex, see here, I can clearly see is at 3, 2. And like this vertex, see here, it's probably a half minus 3, but just double check it by getting that line, which was this one. Sorry, this line here was this one. And this line here was this one, I think. No, it was this one, sorry. Just set those equal to each other. And solve for the intersection, you get x as a half, so therefore y is minus 3, just subbing it into there. And so that's the coordinate for that one. And then finally, again, solve for the coordinate, this one, which again doesn't look in a particularly nice place. So just set this one equal to that one, and of course you can solve this without too much trouble, and you get this, which is minus 4.5, I guess. And you can of course sub that in to get your y. So those are the 3 vertices, and just now, just put those xy coordinate pairs into here and find which one gives you the smallest p-value. So if you put x as 0.5 and y is minus 3 in here, you get this. So that's our first value. If you put x as 3 and y is 2 into here, you get that. And if you put x as minus 4.5, y is 7 into here, you get the smallest one. And so that's the least value. So again, just check the vertices of the region that you've drawn. That's the standard way that they expect you to do this question in this exam. So yeah, just bear that in mind. This is a complicated way of saying that f of minus 2 is 0, and this is a complicated way of saying f of minus 3 is 21. A factor, of course, just means remainder 0, so it's just saying the same thing, but 0 instead of 21. So okay, good, we can just sub those two results into here. So that's the first one, we can do a bunch of simplifying, and we end up with here. And we can sub this result into here as well, and we can do a bunch of simplifying, and we get down to there. And yeah, this is annoying. That all I did was I just times this one by 51 to get that, and times this one by 24 to get that. That made the A's match, which means I can now just do this equation minus this one. I'm actually not sure what the legality of just typing that into a calculator that can solve simplifications equations is in this paper. I haven't really looked it up. So okay, I just did this the long way around, then divided by 168 to get b is 3, and then just sub b is 3 into here, and you get a is 2, and that will be that done. Use algebra to solve f of x is 0, so we know f of x is this, which you can put the a and b's into to get that. We know that x plus 2 is a factor, so this factorizes to x plus 2 times something else. Now, if you want to do polynomial division, go ahead and feel free to. I just won't because I refuse to. X times x squared makes x cubed, and it's the only way to do it. So to make 2x cubed, which is what you want to expand this out to, you just need to put a 2 here. And likewise, to make a minus 12, you're going to need to put a minus 6 here. Otherwise, you're not going to get this term or this term, right? So I've basically found most of the quadratic I'm looking for. If I just call the middle term plus a, maybe, and then look for the x squared terms, the only way to expand this and get x squared terms is 2 times 2 x squared is 4x squared, plus this ax squared. So therefore, 4 plus a is this 15, and we get a is 11. And so this will be my factorized cubic, which I can then factorize this quadratic to make this, and therefore I have solutions when I set that to 0 of minus 2, a half, and minus 6, and those will be all of our solutions just there. This is just, once you get good at it, much faster than polynomial division, so that's just all that I do. And yeah, draw this picture, of course, obviously, draw it, obviously, just draw it every time. You can now see that just doing some sine rule, sine theta over x plus 3 equals sine 30 over x. So cool, sine 30 is a half divided by is just divided by 2, so that's going to be 1 over 2x. And then we can cross multiply, or even just put that one over there, and we end up with what they were looking for here. Now, we can't do cosine rule on this because we're missing a side length, so cosine rule is not going to work. So what we have to do here is use sine squared plus cos squared equals 1, and just rearrange and use this here. So rearrange this to cos squared equals 1 minus sine squared. Get sine squared is x plus 3 all squared over 4x squared, because 2x squared is just, you square both, so 2 squared is 4, and then x squared is x squared. And then, of course, cos squared is just 1 minus this squared, and we get this here. Expand this out on the top. Write 1 as 4x squared over 4x squared, because that's obviously what it is. And then just take away the numerators because the denominators are the same, and you end up with this. You square root both. Square root of 4x squared is just 2x, because that was what we squared to make it, if you remember, and we end up with what they wanted us to get just there. The fact that the angle is between these two things makes cos positive, by the way, if you draw the cos graph. So therefore, I don't need the plus minus, it's just definitely the plus. Good. Given the size of that is this to this, so ABC is the 30 degrees, so that's 30. So divide by 215 times by 7 for 105. 180 minus these two things makes 45, so this angle is 45 here. And you can use either of these two results. I decided to use this one because I thought I was being smart. So I said cos of 45 is all this, and I'll solve this for x. Now the reason I thought this would be smarter is because if I square both sides here, cos of 45 is 1 over root 2, so cos squared of 45 is just 1/2. And I thought I was being intelligent here, just getting rid of all the square roots, but I don't think it's actually, I think it's, just with this one, you have to then have a root 2 in here, but it doesn't help because you end up having to use quadratic formula on this anyway to get this. Root 72 is 36 times 2, so that's 6 root 2, and then divide by 2, and you end up with this anyway. So I think this was the faster one to use, but who cares? Anyway, 3 minus 3 root 2 is negative. This is a side length x, so it can't be negative, so we reject it, and the answer is 3 plus 3 root 2. Question 7 then, what to the power, or 2 to the power what is 16? Well, that's clearly 4. Given this thing there, now we've got two different bases to our logs here, so we need to look in the formula book where it tells us the change of base law, which basically says log to base a of b is equal to log of base whatever you want, in this case Taylor Swift, because we all want her, to the b, which is this top one here, and then divided by log to base whatever you want a, which is the bottom one there. So that's the key rule. So what I can do with this is I can write log to base 4 of x as log to base 2 of x over log to base 2 of 4. Just putting this number at the top of the fraction, just like here, and this number in the bottom. Now this is good for two reasons. Firstly, I've matched all the logs, but also log to base 2 of 4 is just 2, because 2 squared is 4. And then these 2's cancel, and you get this. There's probably lots of things you can go from here, but I decided to take away this from both sides. Follow log laws to say that this is log to base 2 of y over x. And then I can do 2 to the power both sides to clear out this log. 2 to the power 4 is 16. You can also just recognize from here what we've said here, like log to base 2 of 16 is 4. Therefore, if log to base 2 of this is 4, then this is 16. So they've kind of maybe prepped you for that a little bit. Times by x anyway, and you get what they wanted you to get. Hence, solve this thing. Now, this is really weird. So apparently, if 4 plus 2 log 4x is equal to log 2 of something, that something is equal to 16x. So therefore, if we've got all of this, then this thing here is equal to 16x. And you literally just have to make that realization and then solve it, which is super quick. So yeah, good. Question number 8 then. So this is very standard if you do like regular A-level maths in the UK. This question comes up all over the place. The volume is just pi r squared times h. The volume apparently is 90 pi. Cancel the pi's and you get this. The surface area is pi r squared plus another pi r squared, so that's 2 pi r squared, plus 2 pi r, which is the circumference around here, times the height, which will give you the rectangle of surface area in the middle. So that's all of that. Of course, they want an expression without h in it, so divide both sides here by r squared and put it over here. These r's cancel a little bit, and you get this. The 2 times the 90 makes 180, and that's what I wanted. Given r can vary, use calculus, so ds by dr then. So bring the 2 down to make a 4, lower that down to a 1. This is a 180 pi r to the minus 1. The minus 1 multiplies to make a minus 180 and then drops down to a minus 2. Set that to 0 because we're looking to show a minimum point, which of course first means it needs to be a stationary point. Times everything by r squared to get this, and then add that to both sides, cancel out the pi's, divide by 4 and cube root, and we end up with that. Show this as a minimum, so what we need to do is we need to differentiate this again. So if that's the first derivative, the second derivative, well, that's just a number times r, so the r just goes away. And then minus 2 times this is this. 2 negatives make a positive, and then drop it down to minus 3. If we substitute in 3.56 into here, we get this, which is greater than 0, so therefore it's a minimum. And we're done there. To 3 significant figures, find the minimum value of s. So you go back to the s formula, and you just shove in this into here, and very quickly we get our 2 marks of this to 3 significant figures. Question 9 then, so this needs to be written as 1 minus 2x all to the power minus a half, because it's 1 over, so that's where the minus comes from, and the square root gives us the half. Now we can just use this formula from the formula book, where n is going to be a half every time we see it, and x is going to be a minus 2x every time we see it. And I think if you follow that rule, you get to this. So just make sure I've done that correctly. I've replaced n every time I see it with minus a half, and x with minus 2x every time I see it in this formula. And I'm going up to the cubic term here. If you type all of the coefficients into a calculator, just ignoring the x's, you end up with this, and that will be my answer to the expansion. Now we're going to take a bit of a detour and show this thing here. So 0.96 is 96 over 100. And then we can root this fraction separately to make root 96 over root 100, which is root 96 over 10. And then this 10 can jump up to here to give you this. And then 96, I think, is like 16 times 6, which maybe I should have jotted down. But of course, root 16 is 4, so this is 4 root 6. Rationalize this by timesing root 6 over root 6. Root 6 times root 6 is 6, times 4 is 24. And then halve these both down, you get this, which is what they wanted us to get. Express this in this form, so this is just more rationalizing, I guess. So start here, rationalize by timesing by the conjugate. 1 times this is obviously just the top bit. 5 times 5 is 25. Root 6 times root 6 is 6. 25 times 6 is 150. The cross terms will cancel because of the plus minus by design. And then minus 144. This makes 6 on the bottom. And then we can break this fraction here down the middle to make this. So break it there to get this over this plus this over this. Imagine you were adding these up. You'd just get back to here, wouldn't you? 12 over 6 is 2, and we end up with what they wanted us to get here. Use the expansion with a suitable value of x to estimate this. Now, this is a little bit interesting. Now, this is the same as this, except times by 9. So the first thing I'll say is this result times by 9. Now, I want to try and force this result in here as well. So I think what I'm going to do here is I can multiply that out. I'm going to double both of these to get that. This is just unsimplifying this fraction. And now I can say, well, this is, I think, 90 divided by 5 is like 18. So this is 18 lots of this thing plus 18. And now I can say, okay, well, this thing here is equal to this thing here. So I'm just kind of working backwards up the question. And now this thing, okay, well, if you replace x as 0.02 into this original piece of algebra, you're going to get this is 1 over root 0.96, I think. And this is expressed via this, via our expansion. So if you put x as 0.02 into this, you're going to get this, which we can then work all the way back and say is that. So I think all I need to do is do 18 times this expansion evaluated at 0.02, and then add 18 to the answer. That just gets put in a calculator, and you get your answer just there, and we're done with that question too. Question 10 then, so rearrange that, I guess, immediately, or actually maybe not, just, okay, so when x is 2, so that becomes a 4, y is a, and then solve for a is 10. Okay, fine, whatever. L2 and L1 pass through P, which is this point, so they intersect at 210. Show L2 can be written as this. So L2 is perpendicular. If we rearrange this, we'll get a gradient of 2, which means the perpendicular gradient is -1/2, and then we can use y minus y1 equals mx minus x1, where m is that, y1 is that, and x1 is that. So that's just for L2. And then we can times everything by 2, and we end up with what they wanted us to get, which is good. We're going to need to draw a picture for this for sure. This is probably the hardest thing in the question. L1 crosses the x-axis. Now, when something crosses the x-axis, its y-coordinate is 0. So put y as 0 into here, maybe, and you clearly end up with x as -3. So that's the coordinate there. And likewise over here, put x as 0 into this one, and you end up with, put y as 0, crosses the x-axis, put y at 0 into this one, you get x as 22. Draw a picture. So you've got two lines that look like this. They're perpendicular, remember, and they cross at these 2 points here. Now we've got a point C, MN, such that m is greater than 0, so the x-coordinate is greater than 0, so over here, and the n, the y-coordinate, is less than, so we're in this area here. And apparently, the length of AC, so this is C here. Sorry, this is A here, and this is C. So the length of AC is this length, is this, and the gradient of BC, so this is C and this is B, is a quarter. So let's deal with the gradient first. So the gradient from here to here, well, the distance from here to here is just that 22 minus that m. So that's 22 minus m. And the distance here is n. Now, we're going to get in trouble here because it's very tempting to set up n over 22 minus m is equal to a quarter, because that's just rise over run is equal to a quarter. Now, the reason I haven't done that, and you do see this occasionally come up, is this n here is a positive distance, isn't it? You would just say, oh, this is distance 6. But the coordinate is -6 down here. We know it's negative, or whatever number it is. It's negative. I was using 6 as an example. So therefore, if I just set up n over 22 minus m equals a quarter, this would be a positive number. This would clearly be a positive number, and we're not going to get what we want for m and n. So what I've done is I've swapped that sign there to be -1/4, because that way I'm treating n as a positive number temporarily. Well, no, I'm not. I'm saying this is going to be, I'm saying this needs to be like a -6. And therefore, if this is negative and this is positive, I need it to equal a negative number, because a negative divided by positive is negative. So I've swapped that to be a -4, just to force in the fact that n is negative, and therefore I'll actually solve for the right thing. There's a few other ways of setting that up and making sure you get it right, but that is one way of doing it. So just to repeat that, like if you had the numbers here 10, 6, this gradient would be 6 over 22 minus 10, which would give you a quarter, right? But, like, this needs to be a -6 to be down here. So that needed to change to a -6. And to change that to a -6, I can just change this to what it equals to be a negative. So therefore, I'll have negative equals negative, and it'll be fine. So I think this will solve to give me an actual negative value for n, which is what I wanted. So, okay, well, I need something else as well. I can cross multiply, obviously. I need something else as well, which is this distance here. This is actually easier to do, despite the fact that it seems like it'd be harder, just because the negatives don't get in the way. But again, do the same kind of thing. So the distance here is just n, and again, because you're going to do some Pythagoras and square it, you're not concerned about whether that's positive or negative, which is why this goes well. This is 3 plus m, because you can think of it as distance 3 to here, and then distance m to here, so it's 3 plus m. And then, of course, n squared plus 3 plus m squared equals this distance squared, which is that squared. And we can expand that out. We can also rearrange this for m, just because I don't want to deal with any fractions, and put that into there. And then we can simplify that and square it out properly. So this times this, this times this, this times this, and so on. We end up with this. We can take away 50 from both sides and collect those two things together, and we end up with this. And we've just got this simultaneous equation to do. So I'll ignore the rest of the question. You can put that in a calculator, I guess, with quadratic formula. And you get these two answers. -200 plus 30 is -170, which divided by that gives you -5. The other one is a decimal, which is fine, except when you put it into here, this negative here becomes too big, and m becomes a negative number, which we weren't allowed. We needed m to be positive, if you remember. We needed n to be negative, which both of our results are, but we needed m to be positive. So we're going to need to use this set, that solution there. Now returning to our picture, so I've drawn it nice and big here. I've made C the answer we just found. Finds the area of this quadrilateral in here. So I've just labeled everything I need here. Now there's lots of ways you could do this, but probably the easiest is just to say that this distance across here is clearly 25. Now this vertical height of this triangle here just goes up to 10. So the area of this triangle up here is just 25 times 10 divided by 2. And likewise for this one down here, the area of this triangle is 25. The vertical height of that one is minus 5. Or, I mean, just 5, isn't it? So it's going to be a half times 5 times 25. Just add those two results together, and we end up with the area just there. Okay, so some product rule, I guess this is. So when we're doing this, we're going to differentiate this one and leave this one alone. Differential of this is 4 e to the 4x divided by 32, and then just leave this one alone. And then we're going to differentiate this one and leave that one alone. So leave that one alone first, just put it there. The derivative of this is clearly just 16x minus 4. We can expand all this out. That cancels to 1/8, I guess, and then we can just start expanding everything out. We're going to end up with this, so just expand, 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 and then expand, expand. This all cancels down to make what you want us to get. Now we're going to do a volume of revolution here, so we're going to integrate, so it's going to be pi times the integral of y squared dx. And that's going to be between -2 and 0. Now, y squared this is a product, isn't it? 3x times e to the 2x. So you square each. So 3x squared is 9x squared. And e to the 2x squared is e to the 4x, because you can imagine if you put a little 2, I should have written this down, but if you put a little 2 up here, 2x times 2 is 4x, and so we just end up with that there. Now that's great, because when you pull the 9 out, you realize you have to do this integral. And that seems like it'd be quite hard, except you've just shown that this thing derives to that. So therefore, this thing integrates to that via the fundamental theorem of calculus, I believe that's called. So this integrates straight to that, and so therefore I can just say that integrates straight to this, evaluate it between 0 and -2. When you put in 0, you just get 1 over 32, because that becomes a 1, doesn't it? Into just 1, so that just becomes 1 over 32. And then you take away when you put in -2 into all this, you get this. You type that straight into calculus, you get this, and that'll be the entire paper done. And thanks for watching.